the right, we have a diagram depicting the situation. The line segment from A to B is the first part of the trip. That's a distance of 5 miles in the direction 45 degrees south of east. So that's vector AB. And that's already in standard position because the starting point is at the origin. The vector AC is the standard position of vector BC prime going 1 mile west, so that the vector ends up having coordinates -1, 0. And of course, for this vector right here, the x and y components are the magnitude of the vector times the cosine of -45, the direction, which actually that gives us this horizontal distance right here. And whoops, I forgot to put the 5 right here. 5 sine of -45 gives us this distance right here. And that actually is a 45, 45 right triangle. So you could just divide the hypotenuse by radical 2 to get this 5 radical 2 over 2. There's 2 ways to do the problem, or at least 2. One of them is to use the law of cosines, because this distance is 5, and this distance is 1, and this 45-degree angle by parallel lines cut by a transversal must also be 45. So you could use the law of cosines and say r squared equals 1 squared plus 5 squared minus 2 times 5 times 1 times the cosine of the included angle, and get r that way. But if you're going to use vectors, we're going to use vector addition. We're going to add the x coordinates, add the y coordinates, and this is the vector AC prime. We're going from here to here. That's the resultant vector. And that's 5 radical 2 over 2 minus 1. That's when we add these components, comma, the y coordinate is -5 radical 2 over 2 plus 0. So we stay on the same horizontal line. To find the magnitude, it's the square root of x squared plus y squared. That's the magnitude of the resultant vector. Okay, we could say the magnitude of vector AC is equal to what I called r in the diagram. And the theta, the direction of that resultant blue vector, is the inverse tangent of the y coordinate over the x coordinate. On the next board, I actually show the calculations. Okay, here I did the calculation using the law of cosines. Oh no, no, I used the coordinate addition of vectors to get the resultant vector. Square root of x of 1, x of 2 squared minus x of 1 squared plus x of 1, y sub 1 squared. But x of 1, y sub 1, that's the coordinates of the point pointed to by what I call the vector AB. And x of 2 was this x coordinate minus 1. That took us over to here. So there's the coordinates with decimal approximations of the resultant vector. And so this r sub 2, or r, is the square root of x sub 2 squared plus y sub 1 squared, 4.35. And theta, which is this angle right here, is the inverse tangent of y sub 1 over x sub 2, -54 degrees. So the resultant vector has a direction that's east, -54 degrees south. Okay, and of course you could also specify that angle this way and say it was 360 minus this 54.35. Either way. Okay, there you go. Hope that helped. And if you have any questions, post a comment.